Imagine walking down a bustling, sunlit city street, but the world is whispering its most intricate secrets directly into your eyes. You glance at a towering historic monument, and its complex architectural history subtly blooms in your peripheral vision, perfectly integrated with the stone. A stranger asks you a question in a language you have never spoken, yet their words appear as translated subtitles floating effortlessly in the air between you. This is not a scene from a distant science fiction film, but the dawn of a new era in human perception. We are standing at the precipice of a profound transformation, driven by the arrival of AI-powered augmented reality glasses. To understand this monumental shift, we must look at how artificial intelligence is being fused with wearable optics. Augmented reality is the process of overlaying digital information onto our physical environment, but historically, it was entirely blind to its surroundings. Now, by integrating machine learning, a branch of artificial intelligence where systems improve from vast amounts of data rather than explicit programming, these glasses do not just display information, they actually understand what you are looking at. The journey to this point was paved with bulky headsets and tethered prototypes that felt more like sensory deprivation tanks than perceptual enhancements. Early innovators dreamed of a seamless digital overlay, but the hardware lacked the cognitive engine to make sense of the chaotic, unpredictable physical world. The digital pioneers had set a visionary course, but they were severely limited by the sheer computational power required to process reality at the speed of human sight. The missing link was an intelligence capable of matching the rapid, intuitive processing of the human brain. That missing intelligence arrived in the form of advanced neural networks, which are complex algorithms modeled loosely on the human brain that excel at dynamic pattern recognition. When embedded within the sleek, everyday frames of modern augmented reality glasses, these networks perform continuous object recognition. As your eyes sweep across a crowded room, the artificial intelligence is simultaneously analyzing millions of pixels, identifying chairs, coffee cups, traffic lights, and even nuanced facial expressions in mere milliseconds. The human-machine interface has evolved from a flat screen we tap to an intelligent lens that thinks alongside us. Consider the immediate, deeply personal impact on global travel and human connection. Navigating a foreign landscape is no longer an exercise in decoding unfamiliar alphabets or fumbling awkwardly with translation applications on a phone. With real-time translation integrated directly into your field of view, the artificial intelligence listens to spoken words, processes the complex syntax, and projects the translated text seamlessly into your environment. You maintain eye contact, you observe subtle body language, and the technology bridges the linguistic divide without ever breaking the delicate human connection. This subtle integration fundamentally alters the sociology of modern communication. When the friction of language is removed by a silent, invisible intermediary, the historical boundaries of global commerce, international diplomacy, and personal relationships begin to dissolve. We are no longer isolated by geography or native tongues. The algorithm's impact echoes far beyond simple convenience, slowly reshaping how distinct cultures interact, collaborate, and understand one another on a daily, fundamental basis. But what if the true power of these devices is not just in translating what we already see, but in revealing the hidden dimensions that the human eye cannot perceive? Our biological vision is a marvel of evolutionary engineering, yet it is confined to a remarkably narrow band of the electromagnetic spectrum and strictly limited by our cognitive capacity to process simultaneous variables. AI-powered AR glasses act as a profound perceptual upgrade, capable of pulling invisible data from the cloud and anchoring it to physical objects, effectively expanding our sensory bandwidth beyond biological limits. Researchers at institutions like the MIT Media Lab have long explored this concept of contextual information processing, deeply studying how intelligent digital overlays can enhance human decision-making under pressure. Their findings suggest that when highly relevant data is presented within our spatial environment exactly when we need it, cognitive load dramatically decreases while task accuracy skyrockets. The glasses serve as an external, highly organized memory bank, filtering out the overwhelming noise of the world and highlighting only what truly matters in that specific fraction of a second. This extraordinary capability is already revolutionizing high-stakes environments like the modern surgical operating room. Surgeons equipped with smart glasses can now look directly at a patient and see a highly detailed, three-dimensional holographic overlay of their internal anatomy derived from recent medical scans. The artificial intelligence precisely aligns the digital model with the physical body on the table, allowing the surgeon to effectively see through skin and bone. Vital signs, real-time blood flow metrics, and crucial surgical checklists hover at the very edge of their vision, entirely hands-free, The implications for global healthcare outcomes are absolutely staggering. By reducing the dangerous need to look away from the patient to check distant monitors, these AI-enhanced optics minimize critical distractions and vastly increase surgical precision. This is the binary bridge at its most vital, where the cold, calculating accuracy of machine intelligence directly supports the steady hand and seasoned judgment of a human doctor. The technology does not replace the medical professional. It elevates their natural capabilities to unprecedented, life-saving levels. Yet this profound intertwining of human perception and machine intelligence brings us to a complex, unavoidable ethical crossroads. The real challenge lies in the sheer volume of continuous visual data required to make these intelligent devices function properly. For AI-powered AR glasses to understand your environment, they must constantly record it. Always-on cameras and microphones are perpetually capturing the faces of strangers, the private interiors of homes, and the intimate details of daily life, raising unprecedented privacy concerns that our current society is ill-equipped to handle. We must also deeply consider the psychological friction of a perpetually augmented existence. When every object, person, and physical location can be tagged with infinite layers of digital context, we risk completely overwhelming our biological hardware. The human brain evolved over millennia to filter out irrelevant information, but what happens when a corporate algorithm decides what is relevant? The subtle danger is not just a loss of privacy, but a potential erosion of our natural attention spans, buried beneath an avalanche of hyper-targeted notifications and contextual information. To mitigate these severe privacy risks and dramatically improve performance, leading hardware developers are pushing the absolute boundaries of miniaturization and edge computing. Instead of sending your sensitive visual data to a distant cloud server for processing, which introduces dangerous latency and severe privacy risks, edge computing allows the artificial intelligence models to run directly on the microscopic chips embedded within the glasses. This localized processing ensures that object recognition and spatial mapping happen instantaneously, keeping your most sensitive data securely confined to the device itself. This pivotal shift toward autonomous localized processing represents a monumental leap in the evolution of the human-machine interface. The glasses become significantly less of a tethered terminal connected to the internet and much more of a standalone, highly personalized cognitive companion. They learn your specific daily routines, recognize the unique objects in your home, and adapt to your personal visual preferences without constantly broadcasting your life to external servers. The machine gains a level of environmental autonomy that perfectly and securely complements human agency. Nowhere is this localized autonomy more transformative or deeply moving than in the realm of human accessibility. For individuals living with severe visual impairments, AI-powered AR glasses are not merely a technological convenience, they are a revolutionary gateway to personal independence. The onboard artificial intelligence can effortlessly read street signs aloud, identify the exact denominations of paper currency, describe the complex spatial layout of an unfamiliar room, and even recognize the faces of approaching friends, whispering this vital contextual information through discrete bone conduction audio. By seamlessly translating the visual world into a rich auditory or tactile landscape, this technology actively democratizes access to both public and private spaces. The societal transformation occurring here is profound, shifting the heavy burden of navigation from the individual to an intelligent system specifically designed to bridge the gap between human sensory limitations and the physical environment. It stands as a brilliant testament to how human ingenuity can harness automated systems to restore immense agency and fundamental dignity to millions of lives. And this is just the beginning of a massive paradigm shift that many industry analysts confidently believe will eventually render the traditional smartphone entirely obsolete. We have spent the last 2 decades constantly looking down at glowing rectangles in our palms, physically disconnecting from our immediate surroundings to access the vast digital realm. The ultimate promise of augmented reality glasses is the liberating ability to look up again. As the technology matures, the digital world will no longer be trapped behind a pane of glass. It will be painted directly onto the canvas of our shared reality. But as we eagerly paint this new augmented reality, we must critically ask whose brush is actually doing the painting. If proprietary algorithms completely dictate the contextual information overlaid on our vision, we risk fracturing our shared physical reality into millions of isolated, highly personalized filter bubbles. 2 people walking down the exact same city street might see entirely different advertisements, historical facts, or even digital warning labels, depending entirely on what the artificial intelligence determines is most engaging or profitable for their specific demographic profile. Leading neuroscientists and sociologists are currently deeply engaged in studying this potential fragmentation of human experience. They urgently warn that a shared perception of objective reality is the absolute bedrock of societal cohesion and mutual understanding. If augmented reality glasses become our primary everyday lens for viewing the world, the algorithms governing that lens will wield unprecedented, almost invisible power over human cognition and public discourse. The hard-learned lessons from our early experiments with social media algorithms must strictly guide the ethical deployment of augmented reality. Despite these profound philosophical hurdles, the integration rapidly accelerates, particularly within complex industrial and corporate environments. Imagine a sprawling factory floor where a junior technician is suddenly tasked with repairing a highly complex turbine. Through their AI-powered AR glasses, they receive intuitive step-by-step holographic instructions superimposed directly over the heavy machinery. The artificial intelligence continuously monitors their physical progress in real time, highlighting the exact bolt to tighten and flashing an immediate warning if a crucial safety step is accidentally missed. This specific application is rapidly transforming the landscape of blue-collar work and fundamentally altering the very nature of human skill acquisition. Years of highly specialized training can now be dynamically augmented by instantaneous, expert-level guidance delivered exactly when and where it is needed most. It effectively democratizes highly technical skills and dramatically reduces the margin for dangerous human error in manufacturing, global logistics, and critical maintenance. The workforce of the future will not just use static tools. They will actively collaborate with intelligent systems that seamlessly guide their hands. Looking even further ahead, the distinct boundary between the human observer and the observed environment will blur even more drastically as augmented reality begins to interface directly with our neurology. We are already seeing early, groundbreaking research into non-invasive brain-computer interfaces that allow users to navigate augmented reality menus or select digital objects simply by focusing their mental intent. The human-machine interface is steadily migrating from our fingertips to our eyes, and ultimately toward the very origin of our thoughts. This astonishing trajectory forces us to confront a startling, deeply philosophical question about the ultimate future of human experience. If our perception of the physical world is continuously mediated, digitally enhanced, and occasionally censored by artificial intelligence, what happens to our raw, unfiltered connection to nature and to each other? We may eventually find ourselves nostalgic for the simple days of unaugmented silence, longing for a reality that is not constantly annotated, translated, and optimized by an invisible algorithm. Yet the relentless drive to expand our horizons and enhance our capabilities is a fundamental, undeniable human trait. We have always built ingenious tools to see further into the distance, to understand our universe more deeply, and to overcome our inherent biological constraints. From the invention of the very first glass lenses in the 13th century to the awe-inspiring launch of orbital space telescopes, our collective history is defined by the quest to conquer the limits of perception. AI-powered AR glasses are simply the next, most intimately personal evolution of that ancient desire. Ultimately, this technology represents a profound, beautiful merging of boundless human curiosity and staggering machine capability. As we step confidently onto this binary bridge, we are not leaving the physical world behind or abandoning our humanity. Instead, we are brilliantly illuminating it, unlocking hidden dimensions of data, global connection, and profound understanding. The intelligent lenses we wear tomorrow will not just change what we see, they will fundamentally transform who we are, how we connect with one another, and what it truly means to perceive reality.